Okay, let's get started. Hi, everyone. Welcome to Always Coding. This is our weekly Hacky Hour. My name is Komal Devjani. I'm a developer advocate with Always AI, and I'm joined here by Todd Gleat. He's our model product manager. So welcome, Todd. If you have attended our Hacky Hours in the past, so welcome back. If this is your first time here, just so you know, this is intended to be an interactive forum. So this is your chance to pick our brains, ask questions about computer vision, the topic we're presenting, or anything related to Always AI. So this would be your opportunity to ask us now. So today's focus is on data collection and annotation for model training. So before we get started, I just want to announce that we have a quick poll here. This is our Halloween poll. So I'm going to launch this out and then we can get started. And it should take a couple of seconds to fill out. In the meantime, I will just get started with our initial introduction. So if you have already signed up for Always AI, you want to just go ahead and sign in. Let me go ahead and share my screen. Okay, and here we are. So go to alwaysai.co and you will see a button to sign up here. If you've already signed up, you're signed in, you can just navigate directly into your dashboard. And today's focus is, like I said, on data annotation and data collection. So what Todd is going to do is show you how he created a hand gesture model using our existing model, the hand detection. So let me just go ahead and show you how really quickly you can run the hand detection model, and then I'll hand it over to Todd. So here, when you go into projects, you can go ahead and click on create a new project. We can click object detection, and I'll just call this hand detection. So we're going to go ahead and create project, view your project. And from here, you'll have the opportunity to download the CLI for Windows or Mac, depending on which operating system you're using. So this unidentified developer warning, just FYI, you won't see this for very long. We will get rid of that. So you can be safe and download for your OS. But even if you wanted to get started now, there is an opportunity for you to bypass, and you can check out our docs to learn more about that. But definitely make sure you've downloaded the CLI for Mac. So with object detection, the default model that's added onto your project is the MobileNet SSD. And what you want to do is just delete that because we're looking at hand detection. And now let's navigate to our model catalog, and here we have it. So I just typed in hand under object detection, and the second result we see is hand detection, which is just what we're looking for. Once you're on here, what you want to do is add this to a project. So let's just add it to my hand detection project, and we should be ready to go. And from here, what I'll do is I'm going to pull up my terminal. So let's see, make sure it's big enough for you. And I've already navigated into my directory. And once you're in there, let's just make sure that our model's added. Refresh. Yep, the hand detection model's here. Let's go ahead and configure this project on our terminal. So we're going to hit paste. And I want to save this to my local computer. With that, next thing we want to do is go back to the model catalog and make sure we've specified this model in our app.py files. So go ahead and open up your IDE, open your app.py file. I've already opened it up. And you want to just copy and paste that app.py command in your IDE and then hit save. And then from here, what we can do is AAI app install. And then AAI app start. Okay, it looks like it's working. As you can see, the labels it'll detect will be hand. So I'm going to copy this and paste it on a new browser window. And as you can see, it can detect my hands no matter how I shape them. I can do like weird peace fingers or like L for leader. And that's how you get your hand detection started. So with that said, I'm going to hand it over to Todd to show us how he will add on to this model. Todd?
Thanks, Komal. Hi, everyone. My name is Todd Glead, and I'm the product manager for model training. For this Hacky Hour, as Komal mentioned, we really wanted to start highlighting model training, kind of the toolkit that we have, the supporting tools that we offer for training your own model. And the best place to start, and where I think you'll spend a lot of your time, is in data collection and data annotation. So I'm going to go over a little bit of background on this project, you know, kind of how we came up with it, some of the questions we're trying to answer, and the problems we're having, and then walk through data collection using the data collection app that Lila has demoed on the past Hacky Hour, using some pre-processing tools, FFmpeg, and then go demonstrate some annotation using CVAT, which we have integrated, and then kind of set the stage for next week. So what we're trying to do here is a series. So this first part is kind of data collection, annotation. Next time we'll show you the app that we built with it, and kind of you know, inspire you guys to build your own, and kind of join us and show what you can build, kind of using the same techniques, or at least using model training. And yeah, really, this is my first Hacky Hour, but hopefully we've got, you know, many more to come, highlighting model training. So yeah, let's start with the app that we're doing. So for model training, I guess the first step is to collect the data that you want to inference on. And we've got some documentations. Let me just share my screen here. But so can you see that?
Yep.
So this is always documentation. So we've got some great documents about here in the model training section about data collection, and a lot of the things. So first we go over the start application, which I'm going to show you how to use, but we also have a lot of guidelines. So when you want a really robust model, you're getting images with different lighting, you're getting images from far away, with objects small, with objects close, but that takes a lot of data. You know, the more you want to get different angles, the more you want to get that, the more images you need to train on. And so to kind of reduce that, we tried thinking of a way to reduce the amount of data that you need. And so what we thought of is combining two object detection models. So we thought an interesting project would be hand signals to then connect to your smart home, to do kind of accessible stuff if you're nonverbal, if you're busy, but being able to use hand gestures to interact and have an app kind of react to that. The first step of which is making a model that recognizes different hand signals. And in order to expedite that data collection process, we thought of combining it with the hand model that Komal just demonstrated. And so if we use the inferences that model collects, let me just run that to show you, just to have something backing here. If we use the hand model that the area of interest that picks up, then and we run inference only on that region of interest created from the hand model, then we don't need that variety of depth in our data collection. We can just get really close to the hands, and it really improved that. So let me kind of show you what I'm talking about here. So I'm going to show you with the hand detection model, and then I'm going to contrast that with the model that I built with a couple different signals, and then you can see what I'm talking about in terms of how the detection is going to vary. So this is running the same model that Komal just ran. And I just want to point out a couple things so that I can contrast. So here's my hand. And as I move back, it's still getting the hand. And you can see here this box that is around the hand. And so this box is what we are going to use to run inference on. Instead of running inference on this large picture, we're just going to run inference on this box, which means that kind of the robustness of the data does not need to be as much. So I'll show you how I collect the data, but just let me show you the difference in those models. So what I'm going to do is run the same app with a model that I've created, and this one is trained on 2 different signals. And this one, you'll see where it's kind of lacking in robustness. So you'll see it's got 2 signals, piece and 5. And so if I hold my hand close here, it's got 5, piece, 5, and it has the different signals. But as I move my hand back, it loses it because I don't have any examples of that in my data set. I don't have small hands, which are way close. I only have hands close. But the hypothesis is that by combining those object detection models and running inference on just the region of interest created by the initial hand model, we don't need that variation, and it'll really reduce the amount of images we need to create a usable model. So this model is just about 400 images, about 200 images of 5, my hand, and 200 images of peace sign. And that was in this situation. I'll show you how I capture that. So let me take a break there. And is there any questions before I get into how I collected the data and annotated it and then trained the model?
Yeah. What you just described, the training piece of it, can it be used to build like a sign language model?
Yeah, so that was kind of our inspiration. We're using right now, our model training tool is object detection, which kind of detects specific objects. I mean, there are rotating, so this isn't showing me anymore. But it's kind of it's kind of specific objects, and the issue with sign language, if you look into it, is that it's the motion kind of makes the words, right? So we did some research where it's kind of I don't know sign language myself. I know like for the alphabet you can do it with object detection, but some of the words where you're moving, where it matters where you start, and then the motion changes. So with object detection, you're just kind of taking a snapshot. It's probably not the best tool for getting the robust like sign language and actual kind of different motions, just because it's the relationship and the starting position, the direction you move, and then the finishing position. So something more like pose estimation or something like that. So this isn't necessarily the best solution for this problem, but it's a fun project to do using object detection.
So your recommendation would be to use pose estimation to build a sign language.
My understanding of sign language is you'd probably need pose estimation and probably a hand key point as well, which I've been playing with, because there's for people's names and stuff like that for sign language, you quickly just spell it with your hand. So pose estimation can't get that level. So it's a pretty complex problem to do like full sign language, which would require a lot of programming. So it's a little out of scope. But
is it okay if we is it okay if AB asks a question? So he wants to.
Hi, AB.
Raise his hand. Hey, AB.
Hey, hi. Very nice topic about transfer learning to add more like how we can use our model and then add additional classes to that. That's really a good topic. I just recently did something on that, and I really appreciate this thing. So
Great.
about sign language, I think it would be a good thing to have like a pipeline of a model like that. Like as you said, that you have like do object detection for getting the hands, and then use pose estimation for that, because I'm aware that was the same problem I had as well. I was trying to do something on that. Doing the alphabets is very easy, but doing the signs where we have to, so like for example, show trampoline or something to a person. So there's a motion involved there, right? So
Mhm.
it is not possible to do it with object detection. So pose estimation comes handy, but that is also very difficult. Like it's not easy because getting that data set is very, very difficult. Very difficult. So yeah,
Right, and programming those motions, just because you
somebody
can
has to do
track it
the harder
doesn't.
one.
Yeah, and
Oh,
yeah, just that coding in of those motions. So I guess these are kind of what we're doing is kind of quick proof of concept to be able to
absolutely.
explore without going full, coding in the language.
And sign language has multiple forms as well, like the American Sign Language, and there is in Europe as well. It's not an easy problem to crack as well, but good. I like that. Thank you.
Yeah, and
Great.
it's an interesting problem to solve right now, right? Everyone's trying to social distance and like work from home. So when you're video chatting, right, being able to translate sign language into something understandable for those who don't know the language, it's an interesting problem to solve, particularly right now, because that gives additional utility to those who are maybe hearing impaired or exclusively use sign language. So yeah, that's a good question, AB.
Yeah, and nowadays, like Microsoft and as well, they in their latest conference, I think it was Ignite, they had sign language as a part of like we have closed captions, so they had sign language
Nice.
as well. So as you speak, you have sign languages done on the fly as well. So that is happening. But it was only American Sign Language. So it is like everything is standardized from American Sign Language at the moment. But we had a talk. I think we are digressing. So I think we can definitely speak on this. So this is really important topic. Like,
Thanks,
thank you.
AB.
Yeah.
Okay, Todd, you can
Great.
continue.
Okay, yeah, so now I'm going to show you all the steps kind of do for data set for collecting the data. And like I said, the goal is to, kind of figure out ways just to expedite this process, make it simple. And I think our image capture dashboard does that really well. There's a links to that in our docs, and Lila demoed this a couple weeks ago. So let
Wait,
me.
Todd, sorry.
Sure,
I think there's some follow-up questions based on our earlier conversation, if that's
sure, no
okay.
problem. Yeah,
Okay.
absolutely.
So there's one that says, does Always AI have examples of other applications that rely on time series models? And Ross, he recommended that such examples could be a good starting point for motion-based gesture recognition.
That's interesting. I guess I'm not. Can you clarify, what do you mean by like time series models? So we have a couple applications of running different models on regions of interest. So classically we do it with like image classification. Lila's done it with kind of face swapping or age detection, where first detect the face, then run the age detection model on it, or detecting something with object detection and then running a classifier on it. So those are time series in the sense that you kind of use a model based on the output of another model and kind of get sequential, where like you can start writing your your application to do different things based on the order in which things are happening. Is that kind of what you mean by time-based?
He clarified, he said that by time series, I'm referring to a sequence of input data over time. And I believe Andres wants to add something. Andres, do you want to add something to this? No.
You got your mic problem.
Sorry, Andres.
So I might be able to pitch in for Andreas here. I'm assuming you're talking about like an LS.
Oh, Steve, I think you
muted.
Okay, am I?
Yeah, we can hear you.
Yeah. I responded in his chat. No, we don't have any LSTMs or RNNs or anything like that right now. It's just video and object detection and whatnot, pose estimation and things like that, obviously.
Okay, Ross, I hope that was helpful. We have another question here by David Dodds. He said, do we have software and models that allow a camera to recognize the grip pose for handling a pen and tools? So I remember Steve did a manufacturing application a couple of weeks ago where there was a output feature of whether someone grabbed something from a tray or not. Do you think that would suffice to potentially answer this question? But I think that's a separate application, right?
Yeah, I mean that was I guess to give a history on the hand model. So the hand model is a public model that we found, and it included the data set, and the data set for that model was gathered. There's about 4,000 images, and it was gathered from like a POV view of like someone, you know, wearing a GoPro or glasses, and someone across the table doing interactions with their hands like this. And so when I went to try and use that model for other things, it didn't have any examples of hands, you know, like this or close. So I captured those images and tried to just really add to the robustness of hands in the data set so that that model can be used for many purposes, one of which is like Como mentioned, of tracking hands as they move, and then seeing whether they went into an object or a tray or not. If we're talking about, I mean, I think there's two different, what I think you're asking is like the proper grip of a pencil, where, you know, they teach that to like, is your hand in the right position, or are you grabbing it? And my understanding is, as long as you can gather data with your hand in the right position around a pen, you can then have the object detector be like, yes, your hand is now in the right thing. Similar to what we're doing, where you know, my hand is either flat or in a peace sign, or it would just be adding another sign that you want to do. So it'd kind of be collecting the data of the hand in the correct position. And yeah, I mean, we're talking about the technique of combining it with the model, the hand model, but you could also just get a robust data set of the hand in the right position and plug that into your application.
Yeah, and I think Steve G also wanted to add.
Yeah, so I think we're moving away there. There's a couple of things to think about. What Todd's showing you is object detection with transfer learning, right? And that's what we're focused on today. We started out with a hand, so I think people are now dropping in and saying, "Are you doing pose estimation on a hand?" No, he was doing a cutesy thing, picking up the hand and then showing two different very fixed things of 5 and a 2, you know, or a peace sign, whatever you want to do it. But what everyone's kind of going down to right now is pose estimation around the hand movement, on the key points of the hand movement. And you would need that. Todd is working on a base model for that, but that's outside the scope of this one. So, but if you ever did do that, the first step you would need is to do object detection on the hand, right? And so that's what this model would get you. You get the object detection on the hand, is like he was saying, and then the next thing you start doing analysis on the hand. And that would be more towards the pose estimation piece of it. And many pose estimators, and maybe the one that Todd's working with, also do object detection at the same time as part of it on the system. It's just part of the core model. First step object detection, then show the key points on the hands and how the hand is moving. And that way, once you know the key points, similar to what other people have done around facial recognition and things like that, you can start to build out that more complexity. But today we're just really in object detection. The object he chose was a hand. I understand I choose water bottles. We all know why. Welcome to COVID, right? Very hard, unless Todd's going to park his car or something inside. It's difficult to build a data set. So I just wanted to kind of level set people, because you know, that's what we're going to see as the object, the detection of the hand on it. And then there's some things you can do off of it, but it's not going to be to the level that David was talking about, what AB was talking about, and things like that. Those are going to need a hand pose system, which we are taking a look at, and so forth. But there's basic hand recognition, as you could say, from we've seen with factories. They want to see if somebody's going in and grabbing something. And they can see that by overlapping rectangles and so forth as a core algorithm between the hand gesture and the region of interest, which would be the tray, and so forth. So hopefully that helps everyone. But this is object detection to get us back on track.
Yeah, super helpful. Thanks, Steve.
Yeah, and then you know, maybe we'll do another hacky hour with that hand key points, because I was looking at that, and we do have a model. It's not right. We can show that in a couple of weeks. We'll talk about getting that in. So using the technique that we talked about with combining two object detection models, like I said, that means that we don't have to vary the depth of our hands here. So what I'm going to demo now, kind of the same method that I used to create the initial data set, like I mentioned, is about 400 images, 200 of the 5 and 200 of the peace sign. I'm going to do the same thing and add another sign to it. And this is kind of our thinking, is that I can share the data set, and you guys can add your own signs. And then, you know, next week we'll go over an application that uses the different signs, and you can put different things. But let me just show you kind of how straightforward this is when you don't need to vary it up, and if you know the environment that you're going to be collecting the data. So what I like about this data collection app that Lila built and demoed is that you can really have control over when the objects are in the frame. So, you know, if you're annotating, you're annotating the objects you want to detect. And if I'm annotating this picture right now, there's no hands and there's no signs. So that's just kind of a waste of space and a waste of my time. So what I do is I can get my hand here in the frame and ready to go. I'm going to do thumbs up for this one, and then start the collection. And then I just kind of go across the screen, move up and down, move a little closer and a little farther. And then I stop collection. And that got me about 4 seconds, 5 seconds. And then to vary up some of the background, I'll switch hands, and I'll just move my computer up so it's just kind of white background, and do the same thing, you know, with a different hand, and kind of reach over and go. And I just collect, you know, even 3 to 5 videos with slightly different backgrounds, but I'm still just sitting in my chair, and I don't need to go really far to do that. And, you know, I'll bring in different lights from around the room, turn on the lights in the back, go over to the window to get a little different lighting and shadows on the hand. But it's really, what I end up with is, you know, 4 or 5 3 to 7 second videos, and really find that that's all I need to start this data set. And then let me show you what I do just to do a little pre-processing on this data set. And so let me stop this. and I'll Control C out of this. And then, so what this does is saves in the sample folder of the image collection app. So here in the image capture dashboard, we've got the samples. And so done by the date, this is what I just took. I only took videos. If you take images and videos, you have that. But now I've got 2 videos. One limitation of CVAT is that you only have one, you can only input one video at a time. You can put in, you know, as many images as you want, but if it's just a video, each task can only accept one. So what I do to usually get around that is I will use FFmpeg and concatenate or combine these 2 videos together into one, and that just kind of makes my life a little easier when I'm annotating. So let me just show you. We've got some. So here I'm in the image capture dashboard, and I'll go into the samples. And let's see, the most recent one is the 29th. So that's 29. And see the end of videos. And so this should have my two videos there. And then I'll just use FFmpeg, which I think we have links on how to install that, and use the concatenate command. So this is what I did for previous. So I'm kind of doing this like a cooking show. So I'll show you the trained model with thumbs up added to it after the end. But let me just show you. So you got the output, and then here you have the videos that you are going to concatenate together. So before, I think, like I said, I had 5. Now I just have 2. Thursday, and we gotta copy them. And the result of this will be one video that you can then import into CVAT and annotate. And I'll demonstrate that next. So we've got 2. It's gonna copy them, meaning these are going to exist afterwards, and then into one movie called Thumbs. So here, so this is a movie. You know, it's the size. You can tell that it works. Got the size of both of these together, and now I've got one video that I can then import into CVAT as one task, and I don't have to mess around with naming conventions or doing that. Oh, one more thing that I like to do is kind of manually also sample the videos, just so I can kind of play around with the number. So for this one, like I said, I have about 200 of the hands and of the piece. So I'm looking to kind of keep those the same. I'm looking for about 200 for the thumbs up as well. So I kind of do that with I do that by using FFmpeg again and sampling it till I get the number. So it's a little easier to do it manually than in CVAT. So you can just upload this video to CVAT. You can take every single frame, or you could sample it using CVAT. But there's this way I can do it. And if I sample and only get 30 images, I know, and I take like 2 per second and I get 30 images, I can up it to 4 per second and get 60 images, but I have a little bit more control over the number of images. So let me show you that command in CVAT as well. So if I go into images and then, oh, I mean FFmpeg, sorry. So now I'm in there, and if I do FFmpeg, and now I'm going to sample. So this is, I'm taking the video that's in there, which I believe I named thumbs. I's doing it in place. R is recursive, and then this 4 is the number of images per second of video that it's going to sample, and then this is the naming convention that FFmpeg uses. So it's going to label everything with a thumbs underscore, and then it's going to have 4 numbers afterwards. So it's going to start at 0 and go up, and so this can take with 4 numbers incrementing, it could take, you know, up to 9,999. But we'll see. So I know that this isn't going to be enough images because that's what I used to get 200 images already, and that I had a lot more time in the videos. So let's look at these images, and then so I kind of go in here and see, okay, I've got 73 items, one of which is the video, so 72. So I just know how many images I have, and I can either get more video if I want to collect more data, or I can sample a little more, a little less, kind of play with that. Are there any questions before going to annotation?
No questions yet.
All right, so then I'm getting this ready. We run CVAT through always AI. So the command is AAI dataset annotate, or just AAI annotate. I've got mine running here. Then we go to the dashboard here. You see this is my peace sign and hands. This is the thumbs up. I did those separately, but just to show you what I did, I'll create the task the same way. So we got thumbs. You got to add the label, and keep in mind, if you want to do multiple words, remember the underscore there. We don't like spaces. And then, like it said, click or drag. So this is these images, but if I go back to where I keep them, I mean, so there's some moving around in organization that can happen, and I'll just get these and open, and you'll see the 72 images. And again, if you do a video, that's fine. Here in the advanced configuration, you can take a video, and then here's where you can do some of the sampling configurations that I did manually outside in FFmpeg. CVAT also uses FFmpeg. So if you didn't do what I did and make sure your hand is in the frame, and you know the first 10 seconds or nothing, you can start a little later. If you know that you had to bring your hand down to stop and use your mouse, you can stop a little early. And then this frame step is that configuration I did, where I did 4 per second. This will tell you how many frames it takes. So I think 5 takes 1. Every 5th frame, it'll capture 2 every other frame. But this is a way to do the sampling of a video right here in CVAT. And you can change the image quality, kind of down samples it, but we found the default of 70% is fine. So we're not doing any advanced configuration, so I just do submit. I'll open the task. So this is kind of the review. You see, these are it gives you a little preview of the images, tells you how many frames it is, and we can start annotating. So there's a couple. Annotation is pretty straightforward. You know, not a whole lot to say here. For this is kind of the new interface. So if you have multiple labels here, I just have one. This is where you can choose. This square is where I'm going to draw the bounding box. We are doing object detection, so we need a rectangle around the object. And what I recommend, if you upload a video and your sample is relatively close to each other, there's not a big gap, is doing this track mode. And what that does is it allows the bounding box to persist from image to image, and then it also kind of guesstimates if you space it apart, it jumps in between, and I'll show you that. So the way I do is do one image here, and then you'll see, since I did track mode, that is going to stay there for every image in the series. But if you notice, it just stays in the same place. So the way I like to do it is come to settings, and I switch the player step to 5, and that is the double lines, and I close. So then I click the double, and that jumps forward 5, and I'll rearrange the box on the new. And what you'll notice there, if I go back, it's a little better than it moves it in between those, and then it stays in the new place. So as a first pass, we just take 5 and then move this each time, changing the size, changing the location, and at the end of all of them, you're going to have an okay representation. But then if you go back a couple and notice that this is not right because it's not perfect, you're not moving slow enough, or you're jerking around, then you can rearrange it. And then the goal is to kind of do the least amount of frames as possible, with allowing CVAT to kind of help you estimate, help you get those interpolation between frames, and this really speeds up annotation. So for these 200 images, it was probably 15-20 minutes. For the 400, it goes by really fast when your sample rate, you're coming from a video and you use the track mode. So be sure to save, as you're doing this. I'm not going to annotate everything. Each one has annotations. It's a little tricky if you do the track mode, and you go to a frame. And so here, I remember I switched from left hand to right hand. And if you want to start a new one, so this is the last one of my right hand or my left hand, and it's gone. So then this is still of another object. So this works if you're switching label to label, or if you just, okay, this is not the same object anymore. It doesn't really matter. But if you have multiple objects or something, you push this button, switch outside property, and that stops that one from persisting there. You can create a new one on the new object. If it's just lasts for a frame, you don't want to do the track. You just want to do shape, and that'll just do one frame. But then that other one no longer persists, and the new one persists. And so there's one where they're both there, but this doesn't count, and you've kind of switched over. So all those ones of the other one are gone. That's kind of the tips and tricks. You can always change the label, but for some of these, either visible, changing the label, or removing, it's going to remove or change the label for the whole series. So if this is now peace sign, and I want to use the same box because I just switched my hand to peace sign from this, I can't change the sign because it's going to persist back and forth. I'm going to lose all that thumbs up. So now let's just pretend I've highlighted them all, and then
Just stop for a couple questions.
Absolutely.
All right, thanks. So this one's by Dale. He's asking, how sensitive is it to precision of the bounding box?
You don't have to be super precise. So, you can see here, or tell me if you can see, there is some pixelation around there. But, if some of them you're a little up or a little, I think you're erring on a little outside of the object you want to detect, where there's, a little gap here. but it doesn't have to be perfect. You know, I don't have to go like see, you know, right up next to the pixels or right up here, or it doesn't have to be that precise. And there's different conventions, you know, rule of thumb as far as occlusion, things when they're covered, when things go off screen and stuff like that. If something's, you know, 50% or more off screen, you want to not really capture that, because you can see in something like a hand. I think I had some where it's really big, where it's gonna if it's just my palm or something like that, that could be anything. There's no, the distinct characteristics are no longer there. So I mean, think about that. But as far as going around the shape, it's not required to be super precise.
Makes sense. I hope that answers your question, Dale. The next question is by Ross. He's asking, when the bounding box is moving between frames, is it linearly interpolating between points, or is it using something like optical flow?
I'm not sure what optical flow is, but I think it's interpolating between points both in size and location. So if I go here and this one is smaller, so it'll move halfway between, it'll move like halfway between the two frames and then do the size. But I don't, in this version, it's not doing any model assisted annotation or anything like that where we're using it. But that that is something that we're looking at, especially for this situation, where that's in the list, is where if I have this data set and I have the hand model, everything that I'm annotating should be picked up from the hand model, and then my annotation is done. And as long as I capture those bounding boxes and I switch the label from hand to thumbs up or something like that, so that's coming down the pipeline. We're playing with that right now and writing a fun application to do model assisted training, and which will be really valuable for situations like this where the object you're detecting is a subset of an existing model or something like that.
Sweet. I hope that answered your question, Ross. Okay, yeah, you can continue now.
Yeah, so once you're done, and like I said, I kind of go through every 5 steps, go all the way to the end. Then sometimes, you know, maybe I'll go back 2 frames and then go backwards all the way to the other end. And the way it works is if you touch the box on a screen, it's not going to move it. But if you haven't ever touched it, it's going to move it based on the way you move frames to the left and right. So once you're satisfied, then you export, and we export as a data set in Pascal VLC format. And that will, so this, even though I didn't download everything, that's fine. It's going to give it to me here in a zip, and that is how we ingest it into model training. So we could take multiple data sets in our model training tool. So that's fine. So you see, like, excuse me, combining these two, like hand signs and thumbs up, as long as those are exported by CVAT, then when you run training, we can put both of those into the training command, or choose both of them from the drop down, and it'll aggregate them and use all the labels. But we kind of do that with, if you're concerned about that or have trouble, that's where I use FFmpeg beforehand to combine the images.
What's the reason for saving it as Pascal VOC format as opposed to others?
Sure. So there's a number of annotation formats, and they're kind of derived from the large public data sets, you know, Pascal, Coco, and in their kind of contests that they hold to test out models, you know, accuracy, inference time, and stuff like that. They just just multiple ways of encoding the same information. So I could show you, the information. So this is what I just downloaded. And so Pascal is the annotations in XML format. Something like Cocoa is going to be in like JSON. And then there's, different ways. This Pascal has each XML is associated with an individual image. So you'll see the names correspond inside the XML. You have the image that it corresponds with, and then it's got the objects there and the bounding boxes. But XML is just one way of storing and transferring data. JSON is used for Cocoa, and then if we wanted to, or I think the way Cocoa worked is this is individual XML, but you could also have it as one big XML with just IDs for each one, or one long string of JSON. So the reason we use Pascal is it just our backend TensorFlow for our model training. That's the format that it's expecting.
Okay.
But if you have or find a data set in a different format, I know that Steve Vados, Lila, myself, I think we've all, written some scripts because it's got all the same information in, JSON format or single line to parse it out, write it. And so you'll end up with the format that we're expecting. So we can work with you to use outside data sets.
Beautiful.
Yeah, so this is the format. This is the XML format. It's got the size and width of the image. It's got the object, the label. So if there's multiple ones, there'd be multiple of this object attribute here. And then, so what I did was, let me show you. This is the data set. So these are the 5-piece images. We said there's about 400. And this is, me trying to get different backgrounds just sitting here. These are the thumbs. No, I think that's annotations. But these are the thumbs up images. So I got 235 from before. So total, what I got was like 643 images. And this is of all 3 signs, 5, peace sign and thumb. And then I brought this into model training and added thumbs up. So let's see how that works. This is the app.py. So I did hand sign with the typo, was fortuitous. So hand sign is the new one with all 3. And I'll show you this working with all 3, and then I can show you it combined with the other one to see. But we're really kind of building out the application to go around with it. So I don't want to influence you too much with it. So this, remember the 5 and peace, and now we got thumbs up too. And so this was just taking that initial data set, and I didn't continue. I started from scratch, but what you can, and again, this goes away, so I'm not getting it back here. So we can combine it with that hand model and see if we can get some of those signs, and then next week we'll play with these and see how to interact with some Internet of Things or Internet Act, with appliances to kind of, customize your house a little bit. So I modified, excuse me, the object detector and classifier to, so I need to be kind of 2 object detectors. But again, we'll go more over, we'll have the GitHub and more over the application itself next week. So I need to just change the app.py to, I was using the previous model that only has 2 hand signals. So now I just need to change this. So you'll see here. Where, oh, here we go. So we got 2 different ones. And I just got to change this one to hands. So here's a preview for next week. Oh, see, I've got, oh, I changed the output. Oh, I didn't prep this. Let me just change this. Yeah, so I don't have it really displaying the sign that I'm doing, but I can get that. I might need Lila's help. But is there any questions?
All good. There is one question by Dilhit. He's asking, are you transfer learning the final layer of the classifier or retraining the entire network?
We are not retraining the entire network. So we're using the pre-trained. So the model's MobileNet SSD, and it's been pre-trained on Coco. But we're I know Steve looked into it, but I know we're not. I don't know exactly what layers we're freezing at the end, but we're not retraining the entire network. We're using
we're only training
learning.
the fully connected layers.
Thanks, Steve.
Yeah.
Okay. Yeah, I think that's all the questions for right now. Todd, what do you think? Do you want to give it another go to show the?
Yeah, Lila and I were playing with trying to make it more accurate. So I want to see if we can. I don't know well enough whether what I'm changing is what I previously changed.
There she is. Hey, Lila.
Oh, yes. Yeah, we can try and live debug it. I think I just sent you
Oh yeah, I could just use
a
that
draft,
app.py.
and I put in with the A for hands instead of hens.
Oh, yeah. See,
So we can try.
So now
Yeah,
we're
that
seeing
works.
this. Okay.
Yeah. I took away the face and stuff in it before, but now you can just see what modifying the object detector and classifier would look like if you just replaced your own model. So then it's a little similar. Yeah, and now you see even when it's small, far away, smaller. Cool.
Looks good.
It's hard to make my wrist turn.
And we have another question here. Does the retraining category need to be within the Coco dataset categories? Are the Coco dataset labels retained or discarded?
The Coco dataset labels are discarded. It doesn't need to be within one of those labels. It really is just kind of leverages the kind of the edge detection, kind of the early stages and that early stages of the network. But you can train it on whatever you want on, and so that's why it's like, you could do hand, or you could do your hand in a specific position. and that's just going to, you know, the more kind of detailed you get, the more data you're going to need on that. And if you're trying to so I mean, part of the issue we're working here is we're trying to differentiate, you know, holding up 2 fingers versus holding up 5 fingers. For holding up 5 fingers, you still are, this is a subset of this. So, you know, we need to kind of play with how much data we need to have the model be really robust at differentiating those 2 things. So this is, you know, limiting the kind of scope by doing it of just the ROI of a different model is a good way, but to lessen the amount of data, but you may need to play with how much data you need depending on how unique or similar your objects are.
Yeah. All right. Well, it looks like we're a little bit over time. Todd, did you have anything else you wanted to share?
No, just kind of wanted to promote next week of working with the app and kind of connecting it to smart home, where we're going to have some things to share there, and then just, you know, kind of opening up to sharing data sets, and we really want to kind of start this engagement of seeing what you guys can do with model training, seeing, you know, what signs you add, you know, kind of what ideas you have of things to do with the signs or models. You know, we'll kind of hope to pique your curiosity next week as well. And then, yeah, just hearing how you're using it and stuff to see. I think I've already got, you know, one idea for those hand key points where that, you know, might want to pick that back up. That's a really cool thing, but that's it.
Sweet. Thank you so much. Yeah, so if you guys enjoyed this Hacky Hour, join us next week for a part 2 where we will do some smart home automation using our hand gesture models. And yeah, as just to kind of like build off of Todd's point, if you are working on something using our model training tool, post to GitHub, tag us on LinkedIn or Twitter. We're at alwaysAI, wherever you go. And we might feature you at one of our Hacky Hours or our blogs, and it would just show some great community engagement to see what you guys are working on. So definitely do that. And let's see, we have one more question. Oh, AB just said, thanks, Todd. Thank you, AB, for joining, as always. And thanks to all of you for joining. And I'll see you next week on Thursday at 2 p.m. Thanks, everyone. Thanks, Todd.